All right, greetings math people. In this video, we're talking about the AC method. The AC method is a method utilized to factor quadratic equations. And it's used to factor quadratic equations that have a coefficient other than 1 for x squared. And those are problems that sometimes can present issues for some students. So the AC method is a very effective way to factor such problems. And of course, when you're factoring quadratics, that can expand to factoring polynomials of higher degrees and even polynomials with rational exponents if written in a proper form. So let's go ahead and get right into it.
Specialized in science and math, original black men, busting thoughts that pierce your mental, the fierce, ripping your section, vocal toe to toe, impeccable, splitting your back, son. Simple as addition and subtraction, black thought, the infinite relaxed one.
All right, so just a few comments here. I just want to show some things about factoring in general before I get right into the AC method. And the reason being is the skill to be able to factor is such a tremendously important skill in the world of mathematics. It's something you learn, first in algebra, in high school algebra, but it's something that's needed in, courses beyond algebra, whether that's calculus, differential equations, linear algebra. The ability to factor is a tremendously important skill. And in fact, it's a skill that college professors for years have complained that many students coming out of high school lacked. So it is a skill that many people going into college from high school are not as proficient in as they need to be. All right, so again, just some commentary about factoring in general, and then we'll build up to the AC method. So I'm going to look at factoring quadratics, and so I'm going to factor some trinomial quadratics. So this is just a basic problem, just kind of remind you like x squared plus 10x plus 24. And so it's a basic thing, and how we factor such problems as we do these two parentheses. And what we look for are two numbers that multiply to give us this number and add to give us that number. And that, of course, would be 6 and 4 in no particular order. And I think if we were to multiply this out by FOIL or whatever you call it when you multiply binomials like this, we, of course, would get this guy in return. And it's a pretty neat deal. Now, in doing this, you got to be careful about the sign. So I'm going to show you just a couple variations of this particular problem and show you where you have to be careful. So say we have x squared minus 10x plus 24 and x squared minus 10x minus 24. So, these look very similar, but, this minus sign here, makes this significantly different from this guy. Now, this guy is very similar to this guy because of this plus sign. But this guy is significantly different from both of these because of this minus sign. And the reason is when this guy is positive, this guy is the consequence of multiplication. So for it to be positive, either you're multiplying two positives or two negatives. And of course, the sign of those two numbers will be found here. If this is minus, obviously you're multiplying two negatives. If this is positive, obviously you're multiplying two positives. So this would really factor the same as this, except it would be minus sign, minus sign. So this would be x minus 6 times x minus 4. Now, sometimes people will incorrectly factor this guy like this. But again, understand that this product has to be negative 24. And so the only way you can multiply and get a negative number is the two numbers have to be of opposite signs. So they can't both be positive and they can't both be negative. One has to be positive and one has to be negative. And the bigger absolute value, we'll take the sign of this number. So just think you're adding two numbers, one positive, one negative, and that sum ends up being negative. That means the number with the biggest absolute value is going to be negative. And another way to think of these when this is a minus sign, because here I think of two numbers that multiply to give me 24 and add to give me 10. If you want, in a sense, you can think here of two numbers that multiply to give you 24 and subtract to give you 10. And that, of course, would be 12 and 2. And then you can think about, which one's positive, which one's negative. Again, in this case, the higher absolute value will be negative. So it would be x minus 12 times x plus 2. So that's just a basic thing of factoring. Another thing you should be very proficient at is difference of squares. So say, for instance, you got x squared minus 324. That's like a squared minus b squared. So that factors x plus 18. 18 is the square root of 324 times x minus 18. That's something you should be very proficient at. And, you know, as long as it's a difference of squares, it can factor it. If it's a sum of squares, say x squared plus 49, this cannot be factored. Some people will say right prime, or you can just write cannot be factored. But, you know, you can factor a sum of squares. You can, of course, factor a difference of squares. So these are the type of problems we see. And generally, these type of problems are not going to require the AC method. Now, the problems that do are going to be problems where there's a coefficient in front of x squared. So a problem like 2x squared, let's say 2x squared minus 3x minus 5. All right, so say we want to factor something like that. 2x squared minus 3x minus 5. Now, the general way we would do such a problem, and I have a proclivity to do these problems in this way, would be something called trial and error, where basically we know that in order to get 2x squared, we're going to use 2x and x if it can be factored. And in order to get negative 5, we're going to use 5 and 1, of course, 1 being positive, 1 being negative. Now, of course, where we place those, you know, changes the value of this number. So for instance, so I'm going to put this in the wrong place on purpose. So I'm going to put 5 here and 1 here. And let's just say I make this minus and make that positive. So this is what we know when we're doing trial and error. I know I'm going to get my 2x squared. I know I'm going to get my negative 5. What I'm trying to see if I'm going to get is the negative 3x. And the negative 3x comes from this product and this product being added together. So when I'm checking trial and error, when I'm doing a trial, you know, I'm checking if the sum of these two products equals this number. If not, I'll try a different way. So here it's not. If you look at it, 1 times x is x, and 2x times negative 5 is negative 10x, and that sum is negative 9x, not negative 3x. So trial and error, you know, you keep on trying things. The more conversant you get with this, you can kind of see where to place the numbers. It's less trial and error. You have a pretty good idea where the numbers should go. You can kind of work out a lot of it mentally, and a lot of times you can place the number in the right place. But just the different things you can try, you know, say, okay, maybe if I make this a plus and make that a minus 1, maybe that'll give me the answer. That would just give me minus x, and positive 10x will give me a positive 9x. And so the other thing you can try is, you know, moving the location of these numbers. So let's say I put the 5 here and the 1 there. And then if you see, if I multiply again, that's negative 5x and positive 2x. And you can see that sum gives me negative 3x. So this is indeed the way this is factored, 2x minus 5 times x plus 1. So that's the trial and error process. And it's a pretty good process. Again, I do trial and error majority of the time. I really don't even use the AC method. But the AC method comes in handy where generally, particularly where these numbers have a lot of factors. Now, this was a simple example because 2x squared, my only options were 2x and x. And negative 5, my only options were 5 and 1. Okay, well, imagine if this was 20x squared. So think of all the different things you can put, 4x and 5x, 10x and 2x, 20x and x. You know, think of all the variations you can put to get 20x squared. And think if this was minus 60, and think of all the things you can use to get 60. 6 and 10, 4 and 15, 2 and 30, you know, etc. So it gets a lot more interesting when these numbers have a lot more factors. And those are the type of problems where the AC method is a very good method, even for someone like me that's very good at doing trial and error. But, you know, if these guys have so many different factors, then the AC method becomes more advantageous. So let's take a look at an example. So we're going to solve this problem using the AC method. I'm going to try to make it, make these numbers have, a good number of factors so you can see why it's a good AC method problem. But I won't make it too funky. So let's say we got 12, let's say 12x squared plus 17x plus 6. All right, so say that's the problem. So I want to factor this guy. Now it's not crazy bad, but it's pretty bad because, to get 12x squared, I can go 12x and x, 4x and 3x, 6x and 2x. That's a lot of trying. And, the 6 is not too bad. I'm either going to go 2 and 3 or 1 and 6. All right, but just, for the sake of understanding this process, just imagine it was a lot more factors, because no matter how many factors there are, the AC method is going to work. Now, let's explain why this is called the AC method. So the general form of a quadratic equation is ax squared plus bx plus c. And this is called the AC method because the principal part of this is multiplying a times c. So if we go back to the problems we just did a second ago, these problems, notice I was looking for a number that multiplied to give me 24 and added to give me 10. I'm essentially going to do the same thing here, except I'm not going to look for a number that multiplies to give me 6 and adds to give me 17. I'm going to look for a number that multiplies to give me 72. That's AC, A times C. That gives me 72 and adds to give me 17. So I think you would agree those numbers would be 8 and 9. All right, positive 8, positive 9. So it's called the AC method because we multiply A times C. And whatever we get for A times C, we look for two numbers that multiply to give us that number and also add to give us the B number. Now, after that, it's going to be factoring by grouping. So what's going to happen is we're going to split this guy into coefficients. So instead of writing 17x, we're going to write 8x plus 9x. So it looks like this. So 12x squared plus 8x plus 9x plus 6. So I haven't changed the value of this expression. I just split this particular guy in a way that'll allow me to factor, because I'll factor by grouping. So what that means is I'll look at these two guys and factor out what's common to both of them. That would be a 4x. I can factor out a 4x. So I'll factor out a 4x, and that'll leave me with 3x plus 2. And I look at these two and see what I can factor out what's common to these two, and that would just be 3. So I can take out a 3, and that'll leave me with 3x plus 2. So what will always happen if it's factorable and we're doing the AC method, as these guys would be the same. And so there's a process called factoring by grouping, which you should have learned, where this turns into 4x plus 3 times 3x plus 2. And there it is factored there. Now, again, the good thing about the AC method, it's a foolproof, very effective method of factoring these type of quadratics where you have, a coefficient other than 1 for x squared, where I don't have to go any trial and error. I just have to, figure out numbers that multiply to give me AC and add to give me B, and everything else is the same. There's just a little bit factoring by grouping. So again, if it's something that's difficult to figure out through trial and error, and again, this one, could have, this happened to end up being 4x pi by times 3x, but I could have first started off with 12x and x and 6x and 2x, and, could have gone from there. So it's a very effective method. So let's just look at a couple of more examples of factoring these quadratics utilizing the AC method. All right, so let's try another example. So let me think of a good example to use. So let's say 20x squared. 20x squared plus 22x minus 5. All right, 20x squared plus 22x minus 5. That actually, I don't think that's the problem I wanted. So let me look at this again. I was thinking about two different things. So yeah, so I'm gonna make this 21x. I apologize. Let's make that 21x. All right. So please forgive me, math gods. You know my intent was genuine. All right, so this is a problem. Now, it's not terribly bad. Now, the 20 is bad because there's a lot of factors that'll give us 20. But, you know, -5 is just 5 and 1. So this probably could have made that number a little bit, made this number more factors. But anyway, let's deal with what we have. So we're going to multiply a times c. And so that's 20 times -5, -100. And I'm looking for two numbers that multiply to give me -100. Now, bear in mind, this is a negative number. And add to give me +21. So again, for it to multiply to give you -100, one number has to be negative, the other one has to be positive. And the bigger of the two absolute values of those two numbers should take this sign. So the bigger absolute value should be positive, the smaller absolute value should be negative. And again, another way to think of it, you know, numbers that multiply to give you 100 and subtract to give you 21. And hopefully if you think it like that, you'll think it's 25 and 4. Now again, this is the bigger absolute value, so it should take this sign, and this guy should take the opposite sign. So here you can clearly see if I multiply these two, I'll get -100. If I add these two, I get 21. All right, so we're gonna split this, and I meant to mention this in the previous problem, so let me just go back and mention this. So the part, when I get these two numbers, here I got 8 and 9, and I split this guy with these coefficients, it doesn't matter which one I put first. It's all going to work out the same. Some of it may look different at first, but in the end, it will all be the same. So I think I got enough space to show it on here. So let's say I put the 9x first and the 8x second on this problem. So see if I have room to work it out up here, just to show I'm going to get the same thing. So say I did 12x squared plus 9x, and then plus 8x plus 6. And then still we factor out what's common. In this case, what's common would be 3x, and that would leave us with 4x plus 3. And what will be common here would be a 2, and that will leave us with 4x plus 3. And you see in this case, the thing that's common is 4x plus 3, but when we group, we'll have 3x plus 2 and 4x plus 3. So just demonstrating, it doesn't matter which one I put first. All right. So let's go ahead and get to it. Now, what I generally like to do, but it's not a big deal. What I generally like to do, however, you know, if one of these numbers, if one is positive and one is negative, you know, I like to put the negative one first, just for the sake of factoring. But it's not something you have to do. But I'm going to put the -4 first. So I'm going to go 20x squared minus 4x plus 25x minus 5. So again, what we're doing, we're splitting this 21x and making it -4x plus 25x. All right, so now we factor out what's common to both terms. So here would be a 4x, so we take out a 4x. That'll leave us with 5x minus 1. And here what's common to both these will be a 5, so we take out a 5, and that'll leave us with x minus 1. And so if you notice, this is 5x minus 1, I'm sorry, 25x, factor out of 5 is 5x. So what you'll notice, and this is true, what I was about to say is, for the first two terms, there'll be some multiple of x you'll be factoring out. And for the last two terms, it'll be just some constant you're factoring out. All right, so again, these should match, and they do. So we have 4x plus 5 times 5x minus 1. So I hope you're seeing the beauty and the great effectiveness of this particular method. I'm going to do one more example. We're a little over 20 minutes, so I want to bring this video to a close, but let's just do one more example. And in this example, let me try to, make this number be a little bit better than I have previously. All right. So let's see what we can do here. Let's go 10x squared plus 23x plus 12. All right, I think that one's okay. This one has, a few more factors. I guess I could have made this one. Now this one only has two pairs of factors, 10 and 1 and 5 and 2. But hey, we got what we got. So let's find the product of AC. That's 10 times 12. That's 120. And so I want two numbers that multiply to give me 120 and add to give me 23. That would be 8 and 15. And so we'll split this into 8x plus 15x. So I'll go 10x squared plus 8x plus 15x plus 12. And then what's common to this looks like 2x. So we'll take out a 2x. That'll leave us with 5x plus 4. What's common here looks like a 3. So we'll take out a 3. And that'll leave us with 5x plus 4. And you know how it works. These are common. So we'll get 2x plus 3 times 5x plus 4. All right, ladies and gentlemen. So that is the AC method. I hope you found it beneficial. To me, it is a very beneficial method for factoring quadratics. I do use it sparingly. Most of the quadratics that I encounter that can be factored, I can normally do it fairly quickly by trial and error. But if ever trial and error is troublesome, I do utilize the AC method. And for a lot of students, trial and error is very troublesome. So you may have to utilize the AC method more than others. All right, so we're going to end this video here, and we will see you next time.
Specialize in science and math, original black men, busting thoughts that pierce your mental, the fierce, ripping your section. Vocal toe-to-toe, impeccable, splitting your back, son. Simple as addition and subtraction, black thought, the infinite relax one.